let's say we have a function x squared minus 3 over x squared plus 1. Now there's nothing you can do to simplify this. Okay? You know, don't think you can cancel out those x squareds. That doesn't work. The plus and the minus screws everything up in that regard. So you can't simplify anything here. There's nothing that can be factored and canceled either. Okay? So we're stuck with this function the way it is. So to do the derivative, we have to use the quotient rule. Okay? No other way to do it. So using the quotient rule, we take the bottom function, x squared plus 1. Now notice I'm putting these in parentheses because it's more than one term. That's really important to remember. So bottom times the derivative of the top. Derivative of the top function is 2x. Minus the top function, x squared minus 3, times the derivative of the bottom, which is 2x. All over the denominator squared. And now we'll simplify. So what I would do is distribute the 2x through. So multiply here, and I'm going to do the same thing right there. So here I get 2x cubed plus 2x. Now I have to distribute the 2x, and I also have to distribute this negative. So you can do it in 2 separate steps, or if you're careful, you can do it in 1 step, because I'm really distributing a negative 2x. So I'll do it in 1 step, because I just feel like it. So 2x times x squared is 2x cubed, but it'll be negative. And 2x times 3 would be 6x, negative because of this, but it'll be positive because of that. 2 negatives. Okay. All over x squared plus 1 squared. Now don't actually FOIL this out and square it. Just leave it in that form. It's easier to use like that. So usually we just simplify the numerator as much as possible. Leave the denominator in squared form like that. Okay. So I'll just collect some like terms. The 2x cubes cancel out. 2x and 6x is 8x over x squared plus 1 squared. So that would be our derivative function. Okay? So just like before, this is now the general expression for the instantaneous rate of change, the general expression for slope. So if we wanted to, if we were asked to find what's f prime of 1, well, now you substitute 1 in for x. So f prime of 1 would just be 8 on top. 1 squared is 1, plus 1 is 2, squared is 4. 8 over 4, which would be 2. Okay. So you could do that with any number. Plug it in and you get the slope at that particular point. Okay? All right, so now I want you guys to try one before we move on. So let's say you're given this fraction for f of x. X squared plus 3 all over 2x. Okay. So what I want you to do with this, I want you to find f prime of x with the quotient rule, and then use that to find f prime of 1. Okay? So take 3-4 minutes right now and work with the people around you to try to get the right answer, and we'll come back and check your work. So teacher, if you could pause this real quick, that'd be great, and I'll be right back. And I'm back. So let's see how you did. The derivative function, using the quotient rule, we'll take the bottom, which is 2x, times the derivative of the top, which is 2x, minus the top function, x squared plus 3, times the derivative of the bottom, which is 2. All over denominator squared. Okay? Do these 2 multiplications next. So this multiplication gives us 4x squared. This one, I have to distribute the 2 and the negative. So that's going to make minus 2x squared minus 6. And square the 2x, that's 2x times 2x, that's 4x squared. Okay, collect these like terms. 4x squared minus 2x squared is 2x squared minus 6 all over 4x squared. And we could actually clean that up a little bit if we want to. I could factor out a 2 from the top, factor out a 2 from the bottom. So that would be like that, and the 2's would cancel. So my final simplified answer would be x squared minus 3 all over 2x squared. And no, the 2x squareds don't cancel out. It doesn't work that way. So just leave it like that. Okay, so that's f prime of x. F prime of 1, we would just substitute 1 in for the x. So it would be 1 squared minus 3 over 2 times 1 squared. 1 minus 3 is negative 2. 2 times 1 squared is 2. So there would be our slope at that particular point. Okay? So that's the quotient rule. Alright, also you'll be given some applications to do derivatives like tangent lines again. So you might be asked to find the equation of a tangent line. And it's just a matter then of using the quotient rule to find the derivative.